Today we'll take a look at absolute value equations. First, a reminder / introduction to absolute value. We call the absolute value of a real number the distance between that number and 0 on the number line. So a positive 3 is 3 units away from 0 on the number line. So the absolute value of 3 would be equal to 3. But negative 3 is the same distance away. Negative 3 is also 3 units away from 0, just in the other direction. So the absolute value of negative 3 would still be equal to positive 3. Writing that as a piecewise function, we can define the absolute value two different ways based on whether x is positive 0 or negative. So if x is non-negative, so positive or 0, the absolute value bars aren't changing the value there at all. The absolute value of x is still just x. But if x is a negative number, we need to negate it again. We need to multiply it by a negative factor as well to make it become positive again. So in order to solve an equation that has an absolute value, we will essentially do something similar. We'll split it into two parts. We'll say if k is greater than or equal to 0, and we'll address why that's important later, right? But the absolute value needs to be equal to a positive or a 0 number. But as long as that's true, we can split this absolute value equation into two. We can write it first as x equals k, just dropping the absolute value bars. Or we also need to consider x equals negative k. Now you may have something more than just an x inside there, and maybe something more than just k, but this is going to be our basic approach. So we'll highlight some steps to solve one of these equations. We kind of discussed that a little bit. If it's not already isolated, we need to isolate the absolute value expression. So get whatever's inside those absolute value bars on its own on one side of the equation. Typically, I'll put it on the left. After we do that, we need to do what we just mentioned. We need to split it up and rewrite it as two equations. That is what we do to actually eliminate the absolute value bars. And we combine those with an or, because one or the other would have to be true, not both necessarily. So what we do is we'd write the equation as is, removing the absolute value symbols. And then we'll write that same thing again without the absolute value symbols, but we'll negate the other side. So we'll multiply that other side by -1. And then once we've got those two equations, solve each one separately. Generally, you're doing the same steps to both, so it's not too hard to do. And then go back and verify that each solution is actually valid. And again, later you'll see why that's important. So suppose we have this equation. The absolute value of 2/3 x plus 3, and then plus 4 equals 10. Again, our first goal would be to isolate the absolute value expression, so we'll get that piece by itself, subtract 4 from both sides, so the right side becomes positive 6. Since that is a non-negative number, we can split it now. We can say, first of all, drop the absolute value bars to write the equation 2/3 x plus 3 equals 6, and then write that same equation again, but with a -6 on the right side. And again, combine those with or in between, because only one of the two has to be true in order to have a solution. So now we're going to solve both of those equations. I generally do it at the same time because, like I said, you're going to be doing the same steps. And so in this case, subtract 3 from both sides of both equations to get 2/3 x equals 3 or 2/3 x equals -9. From there, you've done this a few different ways to solve for x. Maybe you'd multiply by 3 and then divide by 2. I went ahead and did both at the same time. Right? If you multiply both sides of the equation by 3/2, that's going to eliminate the 2/3. Remember, 2/3 times 3/2 just becomes 1, so you have x left by itself. But then on the right side, we get a way to simplify there too. Right? So we've got 3 times 3/2, which is 9/2. -9 times 3 is -27 divided by 2. So it looks like our two solutions would be 9/2 or -27/2. Make sure that those x values actually work. You can go back and verify them, plug each one in all the way back into the original equation for x, and make sure that you get a correct statement. So in this case, that works, right? We get 2/3 times 9/2. Divide the 2's, 9 divided by 3 becomes 3, and 3 plus 3 becomes 6. So take the absolute value of 6, it's still 6. Add 4, we get 10. That looks good. Do it again with the fraction -27/2. We'll end up with the same thing almost, right? We get, divide the 2's, divide 27 by 3. this first term becomes negative 9. When we add 3, that becomes negative 6. And when we take the absolute value, that negative 6 becomes positive. So 6 plus 4 is, again, 10. Looks good. Let's try another one. This time we've got 3 times the absolute value of a half x minus 5 minus 4 equals negative 4. So don't worry about the negative on the right side of the equation yet. If we add 4 to both sides, that becomes 0. There should still be a 3 in front there, but we can go ahead and divide both sides by 3 as well. You could write a 3 there, but then when we divide both sides by 3, the right side still remains 0. So when we split this into 2 separate equations now, we've actually written the same equation twice, right? Half x minus 5 equals 0, and well, negative 0 is the same thing as 0. So we don't actually need to use both. We don't need to solve the exact same equation both times, so we'll just do it once. So 1 half x minus 5 equals 0. Add 5 to both sides, we get half x equals 5. Multiply both sides by 2. It looks like our only solution here is x equals 10. Make sure you verify it, plug it back in, and it looks like it works. Half of 10 is 5. 5 minus 5 is 0. Multiply that by 3, and you'll still have 0. Subtract 4, we get negative 4. So that looks like x equals 10 is a solution. Let's try one more. This time we've got negative 2 times the absolute value of x minus 7 equals 4. In order to solve this one, there's nothing to add or subtract this time, but to isolate the absolute value, we do still need to divide by negative 2. So to do that, we get a negative 2 on the right side, and at this point, we can actually stop. Remember, we said that the absolute value cannot equal a negative number, so importantly, after you've isolated the absolute value, once that absolute value thing is on its own side of the equation, if the other side is definitely negative, then we know that there are no real solutions. An absolute value expression is never going to end up equaling a negative number. So we can just simply say there's no solution. If that's not satisfying for you, or if you're wondering what would happen if you forgot that, let's investigate that real quick. Right, suppose you keep going and you split it up just like we have in the previous problems. We'd end up with x minus 7 equals negative 2, or x minus 7 equals positive 2. Using the opposite sign. Again, I made this in red. Please don't do this. But if you were to try this, you'll see why it doesn't work. We can add 7 to both sides to solve for x. Theoretically, we think x could be 5 or 9. So the problem comes in verifying, though, right? If we were to go back and plug in 5 into our original equation for x, we'd end up with negative 2 times the absolute value of negative 2. And remember, the absolute value of negative 2 is going to become positive 2. So when we multiply by the other negative 2, we've still got a negative number there, negative 4, which is not the same thing as the positive 4 that we started with. You'll notice the exact same thing happen when we use 9 as our other possible solution. We end up with a negative 4 there as well. So no, these are not solutions. They do not work. There are, in fact, no solutions for this equation.